undermine question, also called the weekend question. This is the opposite of the support question for obvious reasons, but also for not so obvious reasons. Okay, copy the title. We're going to start seeing what this is about. The undermine question usually looks like this. Which of the following, if true, will most directly undermine what? The author's hypothesis, the author's claim, the author's conclusion, the scientist's result, whatever, right? So it's basically very similar to the support question, but instead of support, we're looking to undermine. Remember, undermine doesn't necessarily mean make it false, make it completely wrong. It means just make it less likely, which just means maybe it's not 100% true. We're not trying to make it 0% true. Okay, what is the strategy to follow? Very similar to the support question. So we read this, we find the argument, and here, if you didn't copy, well, I hope you copy because I asked you to copy. It's the thing that is different in this question and in the support question from the other questions is that here there's always an argument. We find the argument, we find the conclusion, or whatever the question is asking us to find, the claim, the hypothesis, whatever. We try to predict what will possibly undermine this claim, this conclusion, and then we analyze the alternatives and we use process of elimination as always. So I want you to copy this, pause the video, copy this. It's basically the same as in the support question, but both are different from the other questions. Okay, things you don't do, don't try to understand, don't rush, you don't have to copy that. Now, what would typically undermine an argument? So, what are we usually looking for? Well, we're usually looking for this alternative causes, as I said in the support video. An alternative cause is basically the thing or another possible cause to the same consequence, to having the same result. So, for example, if you got into your room and you see like there's a pool of water on the floor, right? And then you see that your dog is right there looking at the pool of water, right? So you say, oh, my dog pee on the floor. That's your claim, that's your hypothesis. But if right next to that you see like a jar of water without water, or better yet, it's turned over, right? Or a bottle of water that is turned over, then maybe it wasn't the dog. Maybe it's just the bowl of water or the jar of water that spilled. So that's your alternative cause. So if you increase the likelihood that it was the alternative cause, you decrease the likelihood that it was your dog. And if on top of that you have another possible cause, like maybe you have a fish tank or something here, and the fish tank you see that is leaking on a side, then that's an alternative cause, right? So the more alternative causes you have, and actually here you just need one, if you can present an alternative cause, that's going to decrease the likelihood that the original claim or the original hypothesis was true. So instead of blaming the dog, you're going to start looking for alternative causes. Then we have the reverse causation, which in this case doesn't apply. The example that I gave for the reverse causation was alcohol and depression. So does alcohol cause depression, or does depression cause alcoholism? So which causes which, right? So if I say that alcohol causes depression, and the claim of the scientist is that alcohol causes depression, and I find a paper that tells me that no, that depression causes alcohol, then of course that's going to decrease the likelihood that alcohol causes depression. Are you going to tell me, yeah, but that doesn't make it false? I mean, if I find a paper that says depression causes alcohol, I mean, that's not just undermining, right? That's making it false. Well, yeah. The thing is, like, since these topics are usually about science, and in science we don't have black and white, we're just increasing or decreasing the likelihood of something being true or being the case. We're not making it 0% true or 100% true. Then we can find a similar case that doesn't gain the same results. For example, let's talk about the alcoholism versus depression. So if the claim is that alcoholism causes depression alone, if I can find an alcoholic who is not depressed, there you go. Alcoholism doesn't cause depression. And a very common one is like that veganism, people who don't eat meat, veganism causes low levels of iron in the blood. So if you can find one vegan who doesn't have low levels of iron in blood, it means that, okay, then veganism doesn't cause low levels of iron in blood or any other disease, right? And finally, we have a just direct contradiction. Here, we are allowed to have a direct contradiction, which means alcohol causes depression. Instead of just finding another case, instead of finding, one person who's an alcoholic or one person who's a vegan and doesn't have any problems. What we're going to do is we're going to look at the study and say, hey, your study is wrong. Whatever you did in the study is wrong for this or that reason. That's direct contradiction. Okay, copy these causes, pause the video, copy this. We're going to move on. Remember that we find the argument, and I want you to pause the video, solve this question, write down your answer, and we're going to move on to the explanation. Okay, we move on to the explanation. Analyzing the text. We're going to start analyzing the text, looking for the argument. So this is a long argument. It could be shortened, but this is pretty much the long argument that we have, which goes like this. So we have otters that damage the roots of eelgrass, right? And then we have this place in purple that is the Vancouver or near Vancouver Island that we have a lot of otter population. Okay, and then we have the keywords like yet, keywords like finding and hypothesize, because we're looking for the hypothesis. Okay, so what happens next? Oh, the eelgrass meadows are healthier. Okay, so we're going to have a small recap. So we have otters damage the roots of eelgrass. Now, there's a place in which you have a lot of otters, but the eelgrass meadows are healthier. Okay, so we're going to leave that alone for a moment. And then we find the other findings. Here, the finding is that the Vancouver Island meadows have a more diverse gene pool than others. So the explanation will be in this specific place, the place in purple, the meadows have a more diverse gene pool than others. And now, what is the hypothesis? What is the thing that we want to weaken? The hypothesis is the damage to the eelgrass roots, which is caused by the otters, benefits the meadows' health overall. Okay, so what do we have? What is the conclusion? The conclusion is, I'm going to make it smaller so it fits. So the conclusion is, you have damage, right? And the damage increases the health. The health. That's the conclusion. Damage increases the health. Before we check the alternatives, we're going to look for this. We have alternative causes, reverse causation, similar case that doesn't get the same result or that doesn't work, and direct contradiction. We're looking for alternative causes. So maybe the alternative cause will be just as simple as damage doesn't cause the increase in health. There's something else that causes the increase in health. Okay, that will be the alternative causes. The reverse causation will be you first have a lot of health and then you get the damage, which is not so crazy. You could say that these meadows roots are so healthy that they start getting damaged. Okay, that will be your reverse causation. A similar case that doesn't work will be there is another there are these eelgrass plant roots somewhere else who also get damaged, but they don't increase their health. Okay, that will be the similar case that doesn't work. And the direct contradiction will be, oh, you run, this damage doesn't benefit the meadows' health, or basically contradict any of the previous premises. Like, they are not really damaging the eelgrass, or people thought the others were damaging the eelgrass plants, but they are not really damaging the eelgrass plants. Others were actually chewing on rocks. I don't know, but we're going to trying to contradict the hypothesis. Okay, so we have our predictions. We have damage is not the thing that causes health. It's something else. We have the reverse, which is the health is the thing that causes damage. We have the similar case that doesn't work, which is there's another case in which there's damage but there's no increase in health. And we have direct contradiction, which means either the otters don't damage the grass or the eelgrass meadows are not really healthy, or any other case. And with that in mind, we look for the alternatives. If you do this step right and you have a lot of predictions in your pocket, it's going to be easier. But it also takes a little bit more of time. And if you don't practice when you are doing homework, my advice is the same. Do it for superficial reasons. Okay, this is an analysis of the alternatives one by one. So I highlighted different parts of the alternatives, so from what we're going to analyze. You can pause a little bit and analyze this, but we're going to go straight to analyzing each alternative and compare it to the text or to our argument in the text. Okay, so we have A. At some sites in the study, okay, same sites, some sites in the study, eelgrass meadows are found near other populations that are small and have only been recently introduced. So they're saying, okay, there is eelgrass meadows found near other populations that are recently introduced. Okay, but remember, our conclusion was damage causes increased health. And this is not talking about health, it's not talking about the damage. So it's completely out of scope. It's not talking about the topics that we want to be. At several clients not included in the study, okay, another case, not the same case, a different case. There are large, well-established sea otter populations, but no eelgrass meadows. Okay, what is it saying? It's saying that this is, I'm going to let it pass because it's talking about the same thing. It's talking about another site that can be a similar case that doesn't work. And we have sea otter populations, and there's no eelgrass meadows. It's not talking about the damage, though, and it's not talking about the possible health, but we're going to let it pass. We're going to move on to the next one. I mean, at least we cannot just eliminate it right away. Okay, at several sites not included in the study. Okay, so that's the similar case that doesn't work, or possibly the similar case doesn't work. We don't know yet. Eelgrass meadows health, okay, it's talking about health, correlate negatively, okay, so decreased health, this means negative health, with the length of residence and size of otter populations. Okay, what this is saying is like there's a lot of otters, right? And there's a lower health. Okay, we're gonna let it pass, not eliminate it because it's talking about the points that we want. And let's look at letter D. At some sites in the study, so whenever it's in the study, it's talking about the same case. So you have to talk about this case exactly. The health of plants unrelated to eelgrass plant. Okay, they kind of lost us because they're talking about other plants, not the eelgrass. Correlates negatively with the length of residence and size of otters. Okay, yes, there's a negative correlation, but it's talking about other plants. I don't care about other plants. I care about eelgrass plants. Okay, so we have to choose between B and C. Remember, we're trying to weaken the fact. What was the fact that damage caused by otters increases the health, right? So the the prediction, sorry, the conclusion was damage increases the health. It says health here. Okay, so here says at certain size not included, similar case, there's a lot of otter population but no eelgrass meadow. Okay, let's try to analyze this. There are other populations, so there's possibility of damage, but there's no eelgrass meadows. Okay, so there is not really damage then. I mean, they may have done damage to other plants, but we are talking about specifically damage to eelgrass. So this is not really the answer because it's not giving me what I want. I want damage caused by otters on eelgrass caused an increase of health. And here they're telling me that there's no eelgrass, so there's nowhere to compare. There's no way for us to compare. Now we're going to analyze C. I'm going to try to make my handwriting a little bit better. So what it says is that damage, right? What it says, damage increases health. But remember, this is the thing that we want to weaken. This is the thing that we want to make wrong. So here what it's saying is, at cereal size not included, so somewhere else, eelgrass meadows health correlate negatively with the length of residence and size of otter populations. So they're telling me, okay, there's a lot of otter population, so there's possibly damage. Well, there is damage because they say that they do it. There is damage, and there is low. They correlate negatively, which means okay, this is contradicting because what the conclusion is that they improve the health, which means they correlate positively. Like if you have your table, if you had this is damage and this is health, more damage it means more health. But what the alternative is saying is that you have more damage and you have less health. Okay, so this is my answer. Letter C is my answer. I have analyzed it, but if you notice, the way in which I eliminated the other one was a more superficial way, right? I just care about whether they're talking about the same topics or they're giving me the same items as I have in my conclusion, in my argument. Okay, and this is the way in which we're going to do the undermine question. Now, have to remember, we don't really try to make it false. We just try to make it this likely. I forgot about the other quotation mark. So we don't try to necessarily say other populations definitely don't cause damage, or sorry, damage definitely doesn't cause an increase of health. We're saying maybe you're wrong, or maybe this is wrong because it doesn't happen in this case. We're not trying to make it false. I'm saying this because maybe you think, oh, but this doesn't necessarily make it false. This is just another place, right? This is not the same place in Vancouver. So how do I know that maybe this just happens in Vancouver? Okay, whatever it is, we're not trying to make it false. We're just making it less likely. Another thing that it's good for you is that try to practice undermining conclusions in your everyday life. Maybe you already do this, maybe you already like to do this. You don't have to necessarily do it out loud, but when somebody tells you something, when you're watching the news, you're listening to your teachers talk, to your friends talk, we all make logical mistakes. So we all, when we speak, when we think, when we reach conclusions, we kind of reach the wrong conclusions. We kind of reach weak conclusions from time to time. What you can do is when you want to try to practice trying to make conclusions less likely. Conclusions from politicians, conclusions from your parents, conclusions from your friends, from TV, from whatever it is. Try to think of, okay, what will make this not true? Or what will make this less likely to be true? Okay, copy this. Again, if you want to practice exercises, you can do these pages from the Erica Meltzer book. And we're going to continue on the next question, which is the graph questions.